Hey, what's going on, guys? So in this lecture, we're going to talk about FPGAs. Okay, so this is one FPGA demonstration board. FPGAs, right? So what is FPGA? It is field programmable gate array. Okay. So this demo board is from Digiland. If you are interested in, you can go to their website. So this company is making really good FPGA demonstration boards. So that's a very fundamental version of that. It's using the FPGA integrated circuit chip called Artix 7. Right? It's just one of many FPGA chips from Xilinx. So the company's name is called Xilinx. Pretty popular. If you can find out, search online. This is one of the main FPGA manufacturers in the world right now. Another one is probably Intel. So they are making really good FPGAs, super popular. And also this one is called Basis 3. That's a version or the name of the board. So the previous version is Basis 2, but that one I think has been discontinued. You couldn't buy that online anymore. But this one was launched around the year of 2016, 2017, and now it's still pretty popular online. And people are using that one for using this version for educational purpose and for entry-level FPGA programming projects. And we have been using this for our engineering. If you go to my website, engineering 338, that class. So that class used to be taught at Fuller's College, and we have a lab with that class, we have probably 3 to 4 labs with this Basis 3 board. And there's a final project as well. If you are interested in that, you can definitely welcome to my website, electronics.com. Right? Go to there and go to teaching. You can find out all the courses I taught before. And one of them is this class, and go to the lab page, and there are a bunch of tutorials about how to use this FPGA, how to program with it. All right, so this FPGA board is different from, probably you have heard this before. That's the regular Arduino board, and that's a FPGA chip on this board as the core of this board. And on the Arduino board, you have a microcontroller here from Atmel. And I think the version of, I couldn't remember the version of the microcontroller. But however, this is the microcontroller, right? Or MCU for short. And it's programmed by usually C or C++ to program it. And this one has all these logic functions already built inside the chip. For example, you have ADCs, you have I/O ports, you have serial communication ports. For example, UART, I2C, or SPI. So all this logic has been written or manufactured inside the chip. You can directly use it by using a higher level C or C++ language. But for this one, it's not. So there's no such digital logics or blocks. What they have are just logic gate arrays, right? Gate arrays. And people program it. So that's the FPGA. People program this board with VHDL or Verilog. So either of these two languages. So this is pretty popular in Europe, and this is popular in the US and in Asian countries. So that's why we are learning this, because it's easier to get a job out of it. And people program this board using either VHDL or Verilog. Okay, and you don't have all these logic blocks, but instead you have logic gate arrays. So you just program it and make the connections with the gate arrays and make up a different logic blocks to implement the logic you want to implement to the board or to the real life. But this one is different. This one is easier to use, and you can control more advanced digital controlling systems, and to to automatically turn on, turn off, or have multitask management. But you are programming with a higher level language. You are not actually dealing with the bottom level fundamental gate level transistors, and they have different functions. So some of the more advanced, higher level, higher end FPGA board, they have a CPU inside, and they have ADCs. So it's performing more like a microcontroller, but they have higher speed, more cores inside, and it's more customizable, so you can directly modify the logic blocks to be connected to the CPU, right? This one you cannot. Everything has been connected inside and pre-manufactured. You can only using a pretty simple C or C++ to manage it. So if you have more advanced applications, like the companies who really want to make their own CPUs, they probably want to use a FPGA to do it. But for simple applications like just control simple stuff like a remote controller, a drone, or some robot cars, or coffee makers, things like that, it's good enough to use a microcontroller to do that kind of job, right? And if you just buy this single CPU from the market, it's just $2, right? Super cheap. But FPGA chips can be a little bit more expensive, but still not that expensive since the ICs are being mass manufactured in the industry. So probably $2 here and a couple more, like $5 or $10 for this FPGA. Okay, not big deal. But you do want to learn both of them. So in here, in this fundamental logic class, we are not going to do anything about this one, but you will learn this in a microcontroller class we available at Fullest College. It's not online yet, but the goal is I'm going to push it online in the future. But you can take it and to be sit in a physical class to learn how to program a microcontroller. A lot of fun by playing around with that. So for this one, we are not going to program the FPGA. If you are interested in that, you can buy it. If you use a university program, log in into the website account using a student Fullest College email address, you can get this one at around $80. So I encourage you guys to buy one and follow the examples online on my website to complete some of the projects or experiments. It's really beneficial to you guys. If you want to get an internship in the summer or something, if you let people know you know how to program with Verilog and FPGA, it's a big plus. Okay, but however, in this class, we don't have. I don't even know if you have a board or not. Somebody probably don't want to spend $80 to buy it. So we are not trying to make a mandatory experiment or ask you guys to turn it in as a homework assignment. But however, we are going to we'll still program with Verilog, but in a simulation tool, which is free online. You can definitely download it and still get practice on Verilog and try to simulate the curves from there. Okay. All right, just a short introduction to these two types of technologies, which are super popular stuff and great stuff. Can directly, if you know how to do it, if you are good at it, you can get a job immediately. There are millions, not millions, I mean, probably millions in the world, but thousands of job opportunities by doing microcontrollers or FPGAs. So that kind of job, if you search online, it's called embedded systems. Engineers or something. And I have a bunch of tutorials or experiments online available on my website. If you want to take a look, I will show you. Let me put here. If you go to teaching, so go to engineering 338, you can find out all these labs. And I have introduction to FPGA and more FPGA experiments. And finally, there's a project on that. And if you want to learn microcontroller, of course, I taught it. There's a pretty simple ones, a bunch of tutorials for this course I taught in the summer this year, and you can see that it's mainly about microcontrollers, Arduino microcontrollers, and finally the project is a microcontroller controlled robot car. If you are interested in that, feel free to. If you don't have these kits, it's available online on Amazon, or you can just search online. It's just $50. You can buy the entire kit and you can assemble by yourself and program. You can follow all my experiments online here and finally build a robot car family. I guarantee you these things are super practical and they are highly demanded on the job market. People can get a job after they know how to do it, right? Okay, so now let's take a look at the internal structure for FPGAs. So what are they? So I just drew a little part of it. A, B, C, and I have A naught, B, B naught, C, C naught, right? And I have AND gates. So the gates has been prefabricated inside of FPGA chip, so they are there already. Right, AND gates. But you have many more of things like that. And we are trying to implement a logic like A bar C or A bar B bar or B bar C bar. For example, this is a logic you wrote in FPGA in the Verilog version and you download it to the FPGA. It's going to be synthesized into some kind of machine code FPGA can understand, and then finally being implemented to the circuit. So now let's take a look at that. How can we do that? You have ABC 3 signal lines, and you need A naught C, right? So you just make a connection. So in the very beginning, you actually have all these wires like that. And whenever you need that to be connected, it's just going to make a connection. A bar C is going to connect here, and C will connect here. So you have A bar and C goes into the AND gate. And here A bar, B bar, A bar, B bar, right? So it's going to make a connection. And B bar, C bar. This is how that works. So if you zoom in, I mean, it's kind of magic, right? How can you make the connection? Trying to, you can program it to connect or disconnect that intersection here. So if you zoom in, it actually looks like that, right? And like that, probably like that. So for this intersection, it looks like that. And you can freely connect it to any way you like. And every connection node here is actually a transistor, which is a switch, right? You know a transistor is a switch. If you turn it on, you get current flow through the channel. If you turn it off, you don't have current flow through the channel. So in that way, you can turn it on, turn it off, trying to make a connection. If you turn this on, you are making a connection to here. Turn this on, you are making a connection to here, right? So that's the intersection and how you can make the connection to customize the connection by just program it, right? That's the internal structure for FPGA, so understand why it is programmable. And now for the Verilog, for the language itself, I have a example. I'm gonna post that example online just beside the video, and I will have a PPT, PowerPoint slides just for introducing you how to program with Verilog. So you have a bunch of examples in there. If you wanna try it out, you can do it with Vivado. And I will just directly give you some examples to show you how to program it in there, okay? So in the very beginning, before you start anything, you are going to generate the file. For example, I call this file AND gate, right? This is AND gate .v. .v means it's a Verilog file. You can use a text editor to open that and save it as a .v file, right? That's totally fine. And so inside this file, you can program with that module. You start with a module. It's called module. So this entire thing here is a module, like the circuit inside the chip, right? Module, and I call this module AND gate. And in this module, it's like a chip, right? It's an AND gate. Has input A and B, has output Y, A, comma, B, comma, and output Y, and parentheses, and semicolon. That's the first line you want to write. And that is super simple. If it's just very simple combinational logic like this AND gate, you just do assign. This is like a command, right? Assign what? Assign Y, assign which to Y? A and B to Y. And that's it. That's the AND gate. You're done. And then don't forget to wrap it up with AND module, right? So here I have this logic operator for you, and you should know that this one means not in Verilog, and this bar means that's not Y, not L, right? That's a bar on the keyboard. It's something over here, right? This one, shift, and this one. And not is actually this guy, the one beside one, but you want to press shift and this key so you can get a not operator. So that's OR, right? Okay, that guy, that one is OR, okay? That's OR. And that one is AND logic, right? So where's that one? It's 7, right? But shift 7, okay? So I can do an AND gate really easily. And that's just this chip. And you have pins available, you have input output pins available, but there's no signal. If there's no signal, how can you get a simulation? So that's why you need an outer layer here. You need an outer layer. So this layer is really being called a test bench, right? A test bench. It's also a .v file, but you are assigning signals, right? Like whatever signal you are trying to give it to them. And you are also trying to probe it. That's a function of the test bench. So for example, that's this file, the first Verilog file you want to use for this simulation. And then if we do the test bench, that's the second .v file. That's another file. You can generate this file using a text editor and receive it as a .v file. Okay, that's not a big deal. And now, how can you start with this one? So that one, it's also a Verilog file. So we want to start with module, and we call it test bunch, and just empty parentheses. If you are using a Fpga, you need to put input output over there. But however, there's no physical input output on the board, so we are not putting anything here. But however, we are giving signals to it internally from the computer. I'm sorry, because it's a simulation, so we are delivering signals just using the variables. Right? The variables are, you can manipulate the variables using computer just programming like what we are going to program here. And now I'm going to define a register type variable called A and B as the inputs, and also a wire type signal as the output. Okay, so the reason why you use the register type as the input is, it's so when you have some signals being continuously designed or assigned to these signal lines, you want to use a register type. It's kind of like a flip-flop. They have a memory, right, register type, and they have something to save to it, and then they lock it, and then assign another value, like continuously. This is a little bit hard to remember or understand right now, but if you look at the PowerPoint online, I'm going to upload beside this video, you'll find out, when do we want to use a register type, when do we want to use a wire type, when you program more, things like that, you understand this better. So after you have the 3 wires to be connected to the AND gate, like a package, so next step is to assign signals to it, right? So now before you assign the physical signals, you want to tell the simulation tool like which one is being tested. So which one is being tested? You want to use exactly what the name is here for that module, which is it's also case sensitive. So you want to use AND gate. Just write down the name of that module, and you can so that's the name of the module, okay? Or name of the file or the module. And you can rename it here in this test bench. So if I name it as DOT, device enter test, okay, that's the name. You rename it here. In this file, I just call it DOT here, okay? And you have a parenthesis, and now you make the connection. So which one is being connected to where? So you want to let them know you have a signal line called A in the test bench. Here you want to connect to A, and B you want to connect to B, and Y you want to connect to Y. Okay, you don't have to make them to be A, B, Y, which is the same as signal lines in this module, but I just name it the same so you know which one should be connected to which. However, you can name it AA, BB, CC, whatever you want to name. But finally, you need to connect them physically here. The way to do that is you have a parenthesis, you do a dot. So I can change your line. This usually people do it like that. You change the line, you align all of them in one line. But actually, they are the same as you put them in one line. It doesn't matter. It's just being separated by a comma. Okay. So the first one, this is the signal here in this file and being connected to the signal A in the DOT, in the module, in the AND gate, and comma, right? And B, comma, Y, and there's no comma anymore because nothing, right? Because you are trying to wrap up these parentheses. So now you have the connection, and now deliver a signal to it. So you want to start another line and type initial begin towards, and then change another line, trying to start assign signals sequentially. So what are these signals? So you want to verify the AND gate. So in the beginning, you want to give A to 0, semicolon B 0, and then after 10-second delay, you give A 0, B 1, and then delay for 10 nanoseconds again, and A is 1, B is 0, 10 nanosecond, and A is 1, B is 1, 10 nanosecond, okay? And then do not forget to end it. Initial begin and end, right? And don't forget another thing, change the line and end this module. End module. Below that. Okay, that's your Verilog file, that's your test bench, and it should give you a simulation. So I won't just stop here. So what I'm gonna do is I will run this simulation for you in Vivado, so you won't be that nervous when you are doing the homework. Okay, so I can type Vivado here and start the program. Yeah, sometimes it takes a while. You know, it's software is pretty heavy. Come on, that's too slow. Anyway, so here's a tutorial PowerPoint, or I convert it into a PDF version. So I will upload it to Canvas. You will see that, and also some of the examples here, Verilog examples, I will upload online as well for a reference. So now I have Vivado already started. Wait, so where do we want to find out Vivado? Let me show you. So type Vivado and go to downloads. It's actually from Xilinx official website. Okay. Scroll down to the wipe pack version, this one, and you probably want to register online. Use your if you have Windows system, download this one. If you have Linux system, download this one. Don't get messed up. And create a account on Linux on Xilinx website, and you need that email address and password to log in order to download it. You know, so this is what you need to do. You have to do it because you have a homework assignment for simulation. So go ahead and download it to a computer and run the simulation. So now I'm going to show you how to run the simulation. So you start with create a project and go to next and name the project. For example, I will name it as test and gate. Okay, and next, just keep it by default. It's an RTL project, and you don't need to add any file right now. You can create it later, right? So next. So now something you want to pick up. That's for the FPGA device you are trying to use later. We are not doing an FPGA project right now, but you still want to probably pick up the correct one, right? So choose general purpose for this option, and then RTX 7, which is a FPGA chip, IC chip on the board, and the package is 236, and use -1 for here, and use, don't change anything there. And now you can find out there are 3 options left. So it's like a filter, okay? Just give you 3 options left. And the one you want to use is this one. that's the one we are going to use for our FPGA. So it's 35. That's a keyword. That's the difference between the among these three. So pick up the 35 one and go to next, finish, and now you should be able to start a project. And I will show you how to do the simulation. So the first step is go to the design files. So here's the source file. You can maximize this window just for now, and select that one, right click, and go to add source, and create a design source, the middle one, and go to next, and create file, and name the file as, for example, you can name it as AND gate if you like. Yeah. And then finish. Okay. Yeah, don't do anything here. You don't need to do anything here. Just and then you should be able to see that Verilog file here. Here we go. Right, and then double click, and that's your program interface, and try to maximize the window and minimize this here, the description here, or you can delete it, whatever you like. And they give you this time skew, so it's a prime time skew. So it's not actually a prime. It's the same key. It's actually the key. That little thing here is this key on the keyboard, right? Without the shift. Keep in mind, it's not this one, right? It's one on the left top corner. All right, let's come back. And 1 nanoseconds is the time unit, and 1 picosecond is the resolution. So that's why when you put a 10 here, that means 10 nanoseconds. Okay, now you have the module, AND gate. Let's start programming that. We have a parenthesis here. Let's try to organize this in a better look, and we'll put input. We have A, B as the inputs, and don't forget the comma, and output. You have Y as the output, and change the line. And yeah, just do assignment. This is the simplest FPGA Verilog code we can have, right? Assign what? A and B assigned to Y, right? And actually that's it. We are done for the AND gate. That's just a simple AND gate. And the next step, just go to the design source menu and right click, trying to add a test bench to it. Create a file, call it test bench, right? And finish. Okay, don't worry about that. And then you'll see that file here, right? So now they're in parallel. Keep in mind, you'll see a difference. So if we add this file as a DOT, device enter test, underneath this test bench, so after that, this one will be affiliated to this test bench. But now they're in parallel. They're in the same hierarchy. But later on, after you type the name of this AND gate inside this file, it's gonna automatically detect that change, and then we'll change the hierarchy. So now let's maximize this window and minimize this description. So remember that since we are not using FPGA, so there's no input-output physically, but we still have a register type A and B here as inputs, and we have a wire type signal like that. And now we need to make the connection. So now the critical part, right? You want to call this module, right, in the project and rename it as DOT, and now make the connection. So the connection is you want to connect the A to A, right? And you want to connect the B to B. Oh no, should be a comma, not semicolon. And you want to connect the Y to Y. And now you are done. No comma anymore. Don't forget that. And then a parenthesis and semicolon. So after make the connection, you want to start assigning the signals. Initial begin, right? Initial begin. So what are they? It's just A equals to 0, and B equals to 0 in the beginning and with a 10 nanosecond. And then A equals to 0, but B equals to 1. And so what we are doing, we are just trying to try all the combinations for the two inputs for the AND gate, so we can verify the logic if the logic is correct inside AND gate. And don't forget to end it up. All right. Wait, do I have any errors here? Initial begin, what's the problem? So no semicolon here, is that right? I don't think so. Initial begin, end. Yep, I do need semicolon, 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 right? Yeah, so what's the problem? Let me save it. Warning, extra semicolon is not allowed here in this dialect. Extra semicolon. I don't have extra semicolon here. I think that's right. So let's run synthesis and see what's going to happen. Yeah, let's run it. Run synthesis. I think I'm going to get some warnings or something. I don't know why they don't like that. Oh, initial typo here. Sorry. Initial begin. Here we go. So the errors are gone. And now let's run synthesis. Okay. So after the synthesis, do not do implementation because the implementation is for Fpga, which is a physical programming with a board. But now you are doing a software simulation on the laptop. Right? And it does has a different format here. Right? And there are millions of examples online for how to program with Verilog. If I don't have enough examples for you guys to practice, you feel free to search online when you are doing the homework. Okay, I cannot give you every example for the homework, but if you need any help, you can ask me, send me an email. But I think the most efficient way is find out some tutorials of Verilog online to get it done. Since we won't have pretty difficult assignments for this, because this is not a, see here, do not run that. Okay, don't run it. And then the next step will be simulation. Run simulation, run behavioral simulation. Okay, now let's see. Yeah, we don't have, this is not a embedded system class. So this is the last lecture you are going to have for this semester, for this online course. So the purpose is just to let you play around with it, just have fun and get some result, get excited. But there's nothing require you to manage, to be a pro on that. Okay. And you may have a question, what's going on? They are all ones. Okay, so now this is a very common problem. Look at the scroll bar. It's on the far right side. So scroll it back, okay? And then there are all zeros. What's going on? Then what you want to do is press Control on the keyboard and scroll the scroll key on the mouse, and you can bring everything back to the monitor. So now I can see that these are the signals we assign to them. Look at that, 10 nanosecond, 0 nanosecond, 10 nanoseconds. So which is correct because we assign A0, A20, A equals to 0, B equals to 0 in the beginning for 10 nanoseconds. And then after 10 nanoseconds, we change the state to 0, 1, and then 1, 0, and then 1, 1, right? And all the following, we just didn't do anything. They're all ones. But now I can see that the logic is correct. It's an AND logic, right? 0, 0, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. So if you can show that and do a snip do a snapshot here using the snipping tools on Windows or any other snipping tools on Mac, whatever you have, right? So in Windows, in a PC, you just press this key on your keyboard, this key, right? You press, you can bring up the start menu and just type snipping tool and press enter, right? Now you have a snipping tool here. And now what you want to do is go to new and grab this image and copy, paste to your homework. If you have a Word file, for example, yeah, let me show you. I copy, right? Press this key, and I'm doing my homework. I create a new file in Microsoft. For example, I call it homework1 or something, and go to there and Control V, so you can copy and paste this figure in there and make some description. And also don't forget to have your code. Yeah, just make us no, sorry, go to new and do this and copy and then paste, right? So that's what you want to do for the homework. And this is exactly the same stuff as when you are doing your simulation with LT Spice. You can make a figure from there and copy and paste into your homework. And don't forget some narrative contents, just blah blah blah, saying what is that, what is that, what is that, in this following figure, what just happened, and in this figure, what happened. Just how to do the homework and save, right, and then upload to Canvas. That's how to do the homework, right? So that's an example for AND gate. Definitely you can do an OR gate, you can do NAND gate, NOR gate, XOR gate, whatever you want to do in this kind of form. And you can even make a mux, 2-to-1 mux, 4-to-1 mux, and I will put example of these ones over there, so you don't have to program by yourself. And what you need to do is just copy and paste the code into your Vivado and run the simulation and verify that. And let me know if your result is making sense. Okay, this is everything you need to do for this class. It's not a Fpga class, so we are not asking you guys to become a pro after this. It's just to get you started. If you want to try to learn more by yourself, or you want to take embedded system class in the future, and you can get an internship in the summer. You just, for you guys, probably you can get a job after graduate just by programming Verilog. Okay, very useful stuff. All right, thank you for watching, and that's I believe this is the last lecture we are going to have for the online course, and I hope you learn a lot for this class. And if you have any questions, feel free to email me, and I will be able to help you as soon as possible. And all right, thank you for watching, and I'll see you in any of the meetings or see you in the future. Okay.